Page 665, continuing lesson 11.1 on simplifying rational expressions. Sometimes we will get things that look really close to each other, but they're not identical. If they're not identical, you can't cancel them. Sometimes what you can do, though, is you can factor out a negative, and that allows you to cancel out some like factors. So, for example, if you look at problem 3, they're asking for a simplified form of that. So, a little different look, but in the numerator, 4 minus x squared, that's a difference of squares. We're more used to seeing x squared minus 4 than 4 minus x squared, but it's the same idea. That's a difference of squares, so that can factor as 2 minus x times 2 plus x. In the denominator, you can factor out a 7, and that leaves you with x minus 2. Now, if you'll notice at that point, in the numerator, we have a 2 minus x. In the denominator, we have an x minus 2. Not quite the same. Even if we rearrange them, this would be negative x plus 2, which is still not the same as x minus 2. So what we can do, though, like the book talks about, is we can factor out a negative. And if it helps you to rearrange those first, you can. But then if you factor out a negative 1 times what to get negative 1x, and that would be x. Negative 1 times what to get a positive 2, and that would be a negative 2. And so if you'll notice, by factoring out a negative 1, all of a sudden we have a x minus 2 factor. And once we have an x minus 2 factor, then we're allowed to cancel those out. We're allowed to reduce those factors down to 1s. And then I'm not a big fan of how the book is putting that negative right next to their fraction bar where we can hardly see it. I would probably just leave it up here. And you might ask, they have it as 2 plus x, and then now they switch it to x plus 2. It's just normally they'll write it in standard form. They'll write it with the higher powers of the variables first before they do any constants. So that's why. You could also, if you distributed that, you could also just write it as something like this. That would be fine also. And again, the restriction there is that x cannot equal 2. That would have made the denominator equal to 0. So the top of the next page, we have some got it questions. So same idea. What's the simplified form? State any excluded values. So if you look at number 3, part A, there's actually, as far as factoring out a greatest common factor, there's nothing we can do with either one of those. There's nothing in common in the numerator. There's nothing in common in the denominator. But if you'll notice, those are very close to each other. They're kind of the same, only they're switched around. So again, if you want to, in the denominator, if you want to physically switch those around, just make sure you keep track of what your signs are when you switch that around. That would be like negative 2x plus 5. In the numerator, we have 2x minus 5. So So 2x minus 5, if you want to just leave that alone, and then in the denominator we can factor out a negative 1. And what should happen, hopefully, is that this will end up giving us 2x minus 5. So let's see, negative 1 times 2x is negative 2x, and negative 1 times negative 5 is a positive 5. So that works. Excluded values, if you'll notice up here, if we say the denominator can't equal 0, if you would solve that out. negative divided by negative is a positive, so that would be x cannot equal 5/2 or x cannot equal 2.5. And then once we got our excluded values, now we can cancel these out. We've talked about before, when you cancel, there's nothing left. You can put a 1 there in the numerator since there's nothing else there otherwise. And then 1 divided by -1 would be -1. So -1 is our answer as long as x is not equal to 5/2. So next, if we look at part B, numerator maybe looks familiar. Denominator, there's nothing we can factor out of that. So since that's a difference of squares in the numerator, we can factor that as y plus 4 and y minus 4. Middle terms cancel. That would give us y squared minus 16. And then if you want to put the denominator in parentheses and then kind of think about that, we've got similar factors but not identical here. So since the numerator is maybe more familiar territory for us, we're used to seeing the y terms first. If you want to just keep those the same, and then in the denominator, again, if you want to actually rewrite this so it's in the same order, you can. If you want to just do that off to the side, I'm okay with that. If you'd rather do it as a separate step, that's fine too. And then what should happen is if we do -1 times the quantity y minus 4, if you distribute that, that would give you -1y plus 4, which is what we had. And again, if you just want to look at it and say, well, I'll take my chances here, this is what I had, I'm just going to try to factor out the -1 and then distribute and then think about if it matches with what I had without switching them around. You can do that. For me, I like to have it switched in the same order. I think it's easier to look at, but that's kind of a personal decision there. Before we cancel anything, we had 4 minus y in the denominator, so that can't equal 0. If you want to add y on both sides, just to give you a positive answer, then you don't have to divide by -1. Basically, then y cannot equal 4. And then we've got these y minus 4s we can cancel. If you'll notice the way that we did this, it's y plus 4 divided by -1. So probably what they're going to do is divide each of those parts of the numerator by -1. And so that would basically just change the signs. So -1y minus 4 or just -y minus 4. So if we look at part C, difference on part C here is that we have a trinomial in the denominator. So we can try to factor this. One thing if you want to do ahead of time is you can, a couple ways you could do this. One thing you could do if you want would be you could rearrange the numerator. And then if you think about it, in the denominator when you factor those, they're going to be something d plus something or something d minus something. There's not going to be a negative in front of either of our factors. So you might notice in the numerator we have something we can factor. We might also factor the negative out with that as well. So there's a 3 in common with the numerator, but if you want to go ahead and factor the negative out, because we can kind of see where this is headed here, -3 times 3d would give us -9d, and then -3 times -1 would give us a +3. And then that leads me to believe that I'm probably going to have a 3d minus 1 factor as one of my factors in the denominator. So the other factor we know, we had a 6d squared, so 3d times 2d would give us 6d squared. And then at the end we had a minus 1, so negative times a positive would give us a negative. 1 times 1 is 1, and then we can just double check this. This would be minus 2d plus 3d gives us plus 1d, so that works. And again, if you want to, if it's more confusing for you to put the one factor there, if you'd rather just act like you're not seeing the numerator and just factor it like you normally would, that's fine also. So excluded values, each of these factors can't equal 0. So we can easily solve those out. Okay, so d can't equal negative 1/2 or 1/3. And then at that point, we can look for factors that we can cancel out. So we've got 3d minus 1s we can cancel. We're still left with things in the numerator and the denominator, so we should be good with that answer. Again, there's nothing it could even cancel with possibly, but like I've said before, if you want to just put parentheses around the 2d plus 1, that way you make sure you don't cancel unless you see another 2d plus 1 somewhere. And finally here, if we look at part D, the numerator, there is a 3 in common. And like we've seen so many times here already, if you want to rearrange that, you can. Instead of factoring out a 3, maybe we'll factor out a negative 3. In the denominator, we can factor out a 2. And at that point, that might not seem very helpful because we don't have any like factors in the numerator and denominator at this point. So at that point, though, if you'll notice in the denominator, we have still a squared term. When you have a squared term, there's at least a potential you could still factor that. And z squared plus 1 is a difference of squares. So that'll factor z plus 1 and z minus 1. And then we have some factors that are the same we can cancel. Now, before we get in too big of a hurry here, we need to make sure we do our excluded values first. Obviously, 2 cannot equal 0, so we don't have to worry about that part. But if you solve these out, z can't equal negative 1 or 1. So those would be our excluded values, and then now we can factor out the z, or cancel out the z minus 1s. And then I'm just going to rewrite this because it's a little bit of a mess right now. So we could leave it like that as our final answer. If you would ever see one like this and it says negative 3 over 2z plus 2, just understand that that's equivalent to the answer that we have. Problem 4 talks about using rational expressions for real-world situations. So on problem 4, you're choosing between two wastebaskets that have the shape of the figures at the right. They both have the same volume, and they're asking what is the height of the rectangular wastebasket, and give your answer in terms of A. So we would have to go back to our formulas. Volume of a cylinder is pi r squared h. So the radius is A, so it'd be pi times A squared times the height, which is 2A plus 8. And then for the rectangular prism, one way you could look at this rectangular prism, you'd be doing 2a times 2a times h. So that would be 4a squared times h would be that volume. And we're trying to figure out what the height is. So I would have probably done this a little differently than the book. I would have said, okay, this is my volume for the one. The other part I would have done the same as them, finding that volume. And then we can solve for h. If the volumes are the same, we can just set these equal to each other. So to get h by itself, they're multiplying. We can divide by 4a squared on both sides of the equation. So at this point, if you notice, we have factors of a squared that we can cancel in the numerator and the denominator. And then before we just decide we're done, the 2a plus 8 actually has a 2 that we can factor out of that. I'm going to go ahead and put it in front of the pi here. So 2 times the quantity a plus 4 would be 2a plus 8. And it's not always going to work, but in this case, at that point, the 2 and the 4 you can reduce by a factor of 2. You can put a 1 there in the numerator if you want to, but you don't really have to do that. So I know it's not a very satisfying answer, but that's it. That is our height for this problem. So if we look at the got it 4, a square has a side length of 6x plus 2. I would be drawing a picture here. A rectangle with width 3x plus 1 has the same area as the square. What is the length of the rectangle? So the area of a rectangle is length times width. So for our square, we would be doing 6x plus 2 times 6x plus 2. On our rectangle, we would be doing L times 3x plus 1. And they are telling us that these areas are the same. So just like we did in the previous example, at this point, we're saying that these areas are equal to each other. And so what we could do is simply set these areas equal to each other. We set them equal to each other, and now we can solve to figure out what the length is. So to get the L by itself, we would have to divide by 3x plus 1. And this doesn't really look very good right now, but there's one other thing we can do yet. So with the 6x plus 2, there's actually a 2 that you can factor out of that, which would leave you with 3x plus 1. And then the 3x plus 1s we would be able to cancel out here. And you could have factored a 2 out of the other one as well, but if you'll notice at this end part, if there's nothing we can get it to cancel with on this problem, we don't really need to factor it out. And then I would probably go ahead and just distribute that and then say your length is 12x plus 4. Excluded value would be that x cannot equal negative 1/3. which, if you think about it, well, that it would actually work. X could have been negative 1/3, and potentially it could have worked otherwise. No. X can't equal negative 1/3 because that would have made the 3x plus 1 equal to 0. So that would be a reason that can't happen. And in fact, x has to be greater than negative 1/3 for this to work. Otherwise, we'd have a negative dimension on our rectangle. So this gives you an idea of how to work with simplifying rational expressions.